down. That's really good. That's kind of the summary of what we were working on last time.
Okay.
Any questions on that?
No.
Okay. All right, let's do some SAT prep. Let's do some SAT prep today. All right. Let's look at, I don't think we've done any statistics in a while. These are more reading comprehension problems. But
Okay.
let's take a look here. Are you tired tonight?
What?
Are you tired this evening?
Tired this evening?
Yes.
No. I'm not tired.
You're full of energy.
Yeah.
Okay. All right. Will you read this problem out loud for us, please?
Yeah. First, I need to find a pencil.
Sounds good.
All right. Okay.
Okay, so just want you to read this one out loud for me, please.
Okay. The sample of water was taken from each of the 10 different locations in the pond. The pH of each sample was measured. The measurements were summarized in the frequency table shown. How many samples have a pH of 7.4 or greater?
Okay, what do you say here?
I
Can
would
you tell?
say that is going to be 4.
How are you coming up with that?
The reason why is because 4 is the pH for 7.4 to 7.6.
Okay, but this one wants the pH of 7.4 or greater.
Oh, wait a minute. 3.
Well, that is also true, but we want the total. We want the total of that.
The total.
Yes, like we want the combined amount that are 7.4 or greater.
Okay.
So that's both of these numbers, Sourish.
Both 4 and 3?
Yeah.
And you have to add them?
Yes.
7.
Okay, I agree. I don't know why. Sorry, let me just do something real quick here.
Okay.
Yeah, so the answer is 7.
Okay. Yes.
All right, let me grab another problem like this one for us to look at. So sometimes the questions are this simple, like you don't have to do any math. Okay, you don't have to like do anything but count. You don't have to know anything about pH, you just have to know how to figure out what they're asking for.
Okay.
Now, when you asked me last weekend if the questions on the SAT were going to be just like this, and I mentioned, I don't know if you remember asking me, but I told you that they were not going to be exact like this. Like you're never going to see this problem, but you might see a problem where they give you a graph and they ask you something about the graph.
Okay.
Okay, so I want you to start over here on the left and read this out loud for us.
Okay. I'll be reading that.
I'm asking you to read it out loud for us.
The line graph shows the number of space shuttle launches by the U.S. from 1981 through 1986. During which year of the time period was the number of space shuttle launches the greatest? 1985.
1985. Bingo. Which year were they the least?
Well, which year were they the least?
Yes.
Or
Or the fewest.
the fewest, okay.
Either word.
1986. Oh, wait, there's no 1986. It's 1982.
Well, how many were there in 1986?
2.
How many were there in 1981?
2.
Good. So both are correct. That's fantastic. It's really good that you're able to understand that. All right. Now, have you been hiking recently? Have you gone out on the trail at all?
What?
Have you done any hikes lately?
No.
Okay. Well, Marilyn went hiking. Okay. So Marilyn hiked. It looks like she started at 12 and then she ended at 3. Okay. So it looks like she went away from her campsite, maybe rested, went a little further away from her campsite, and then started coming back. Okay.
Yeah.
Okay. So the graph above or to the left here shows Marilyn's distance from her campsite during a 3-hour hike. She stopped for 30 minutes during her hike to have lunch. Based on the graph, which of the following is the closest to the time she finished lunch and continued her hike? When did she finish her lunch based on this
Well,
graph?
she finished her lunch. She finished her lunch. She finished at like. She finished. She finished at 3 o'clock.
Well, that's when she finished her hike.
Okay.
Now question for you. When you ate lunch today, were you seated down?
I did not eat. I do not eat lunch at school.
Okay, how about when you eat breakfast? Do you sit down and eat breakfast?
I don't eat breakfast at school. I eat them in my house.
I know that. I'm asking when you're at your house, when you're eating breakfast, are you sitting down?
Am I sitting down? Yes.
Yes, you are not moving. So the assumption here is that when Marilyn is eating lunch, she is not moving.
Uh-huh.
So here's the point in time where she is not moving. What do you notice about that part of the graph? How would you describe that part of the graph?
How do you describe that part of the graph?
Yeah, how
Well,
would you,
it's between like 1 o'clock to 2 o'clock.
right, but tell me about the graph here, this part of the graph. What's a word to describe that?
A line.
It's a line. It's a straight line. Yeah. So it looks like this is when she started eating lunch. And this other one is where she ended eating lunch.
Okay.
Now, which is the problem asking for?
The problem asking for. It's asking for like based on the graph, which in the following is the closest to time. She finished lunch and continued her hike.
So which one are we
Well,
looking for? When she started or ended her lunch?
finished.
Okay, so what time would you say that is approximately?
I would say the time for dad right there. The time it would be 2 o'clock.
Nope. She's 2 o'clock is up here.
It's wait a minute. It's 1:10.
Okay, I think 1:10 is probably when she started.
Yep.
We want to know when she finished.
She finished around like 1:40.
Yes, very good. Any questions on that?
No.
All right, let me snip in another question for us to look at. Doing great. All right, so I want you to look at this table. Can you read the prompt there? What does it say at the top?
At the top, the number of people who rode a certain bus each day of a week is shown in the table below.
Okay. So the data, the table shows the number of riders on each day. All right. So I'm gonna put a sentence in front of you, and I want you to tell me whether this is true or false. Okay, so first one for you. What's going on here? Is this true or false?
I'm thinking.
Let me ask it to you differently, sir.
I think I know that. I think I know that.
Okay.
I know what that. And the bus had a mo. I know what that is. It's 8:08 at Friday.
No, this is, I'm asking you, is this true or false? Were the most bus riders on Tuesday?
Not kinda.
Well, okay, let me ask you differently. Which day had the most bus riders?
Friday it had.
That's right. So this would be considered false.
Yeah.
Okay. Let's look at another sentence here. Look at another possibility. All right. Each day from Tuesday through Sunday, so that means starting on Tuesday, the number of riders on the bus was greater than the previous day. Is that true or false?
That's true. Each day from Tuesday through Sunday, the number of riders on the bus was greater than the previous. Each day from Tuesday through Sunday, the number of riders on the bus was greater than the previous day. False.
It's false because from Tuesday to Wednesday, it actually goes down. And then from Friday to Saturday, it actually also goes down. So yeah, that one is false. Okay, so let's look at the next sentence here and see if we can find something that is true. Okay, so look at this one here. Each day from Tuesday through Sunday, the number of riders on the bus was less than the previous day.
Yep.
That's true.
No, no. Oh wait, yes.
So Tuesday to Wednesday, it went down. How about from
Oh
Wednesday
wait,
to
no,
Thursday?
it's a false again.
It's false. Yeah. Okay, let's look and see if this one is true or false. Last one here. Okay, can you read that out loud for us, please?
Yeah, the 2 days with the fewest number of riders were Saturday and Sunday.
Okay, is that true or false?
True.
That's true. Yeah, because 480 and 229 are the lowest numbers. Do you think that's true in Tucson? Do you think less people ride the bus on the weekends?
I don't know.
I think it's probably true. There's less bus times on the weekends. At least that was true back when I was going to college.
Okay.
Don't know if it still is. All right. Number of 3D movies released by year. Have you ever seen a 3D movie before?
A 3D movie.
Yeah, like you wear the special glasses. Like Avatar, the first
Yeah,
Avatar
the
was
3D movie
released
I
in
have
3D.
seen is the 3D movie I've seen is the 3D movie I saw the 3D movie I saw is I'm thinking
Okay.
Yes. The remake I saw was Avatar: The Way of Water.
Very good. All right. So this one says the number of 3D movies released by year. So in 2003 to 2004, 5, 6, 7, 8, 9, 10, 11. What's kind of the general trend here, Sourish? What do you see as going on here?
Everything is going on here. Okay, in there,
Like, give me how would you describe the number of 3D movies released by year?
okay, I would describe that between each two consecutive numbers were, I would describe that, I would describe that 2010 to 2011.
So to me, it looks like it's going up. Like there's more releases each year.
Yeah.
Okay, now let's go look at the question here. It says, according to the line graph, between which two consecutive years was there the greatest change in the number of 3D movies released?
2010, 2011.
Yeah, very good. It's excellent. Okay. Let's look at another problem here.
Uh-huh.
All right, I'm snipping it in here. I want you to read this one out loud for us here, starting with the graph, please.
Okay. All right. The graph above shows the position of Paul and Mark during a race. Paul and Mark each ran at the constant rate, and Mark was given a head start to shorten the distance he needed to run. Paul finished the race in 6 seconds, and Mark finished the race in 10 seconds. According to the graph, Mark was given a head start of how many yards?
Yeah, so when you read something like this, it can be so overwhelming. You can think, oh my gosh, there's so much going on. But really, everything you need to know is in this last sentence. Okay, I call this the call to action. It says Mark was given a head start of how many yards? Any idea where that is on the graph over here on the left?
Yeah. Okay.
So what does this say on the left here?
And distance and yards.
Okay, and it's asking for the head start in yards.
Yeah. Mm-hmm. Yep.
So what's the difference between these right here?
Those right there. Oh yes. I think those were between 12. That's why.
So each square on the vertical is 6.
Yeah.
So what's the distance? What's the height difference between these two?
The height difference between those two. And the height difference between those though is 12.
Nope, try again. Maybe there's too many lines here. Let's get rid of some of them. So here's the dot and here's another dot. How far is it between the two dots?
How far is it between the two dots?
Each square is a 6 vertical, 6 vertical.
Yeah. Okay. And that is it like 3?
So each of these is 6, Sarish. So to the second dot, that's 6. To the third dot, that's 12 to the next dot. What's between 12 and 24?
18.
Yes. And that's what we're looking for. All right, why don't we take a short break until 7:32,
Okay.
and I'll check back with you and work on some more problems.
Okay.
All right, Sourish, you ready to get started again and work on some new questions?
Yeah.
All right. So we're going to talk about linear. Oops, let me switch colors here. We're going to talk about linear and exponential.
Linear and exponential.
Yes. Okay, so I'm going to put a problem in front of you. Okay, we're going to read it together. And when you're reading this, or when we're reading it together, I want you to decide if it's linear or exponential. Okay, it says after a new car is purchased, the value of the car is modeled by a function that decreases exponentially over time. Which of the following could describe how the value of the car changes each year? Is this linear or exponential?
Linear or exponential.
If you're not sure, why don't you read it out loud again, and we'll see if
It's fine. It's fine.
we can decode it that way.
Okay. I think I know this. Okay. I know that whatever you know is that each year the $800 can decrease into 8%.
I'm not asking you to do that. In fact, I'm gonna delete that, and we're just gonna look at the prompt again. I want you to decide if this is linear or exponential here. So let me snip it in. Let's try it one more time. Is this linear or is this exponential?
Linear or exponential. That's linear.
Okay, what word in here tells you that it's linear? What word says, hey, this is a linear function?
Okay. I would guess,
Good. I want you to read it out loud for us.
after a new car is purchased, the value of the car is modeled by a function that decreases exponentially over time. Which of the following could describe how the value of the car changes each year?
Okay, what word is this that you read?
Exponentially.
So is this linear or exponential?
That right there is gonna be exponential.
So this is telling you, this word is telling you that it's exponential. Okay, so there's some key differences between linear and exponential. So I'll describe those for you now. Okay, the linear has a slope. Okay, the slope is constant. Okay, it also has a y-intercept. Okay, an exponential does not have a slope, it has a rate. And this rate is a percent. Okay,
Okay.
percent. So exponentials will have percentages in them. Linears will have constant change. This one also has a y-intercept, but it's called the initial value.
The initial value.
Yes.
Okay.
Now I'm going to snip in the answers, and this time I want you to tell me which two answers have a percent in them. Which two answers have a percent?
Which two answers have to present? Two
Yes.
answers that have to present right there. Two answers that have to present. That is C and D.
C and D. Okay, good. So we know for sure that it's not A and it's not B. Okay, now there's two types of exponentials. Okay, there's one that's growth and one that's decay. Growth versus decay. All right, so let's take a look at the question one more time. Is this one growth or is it decay?
This one growth or is it decay? Growth.
Okay, what word tells you that it's growth?
Oh wait, exponential.
There's a word in here that tells you that it's growth or decay. What's this word right here that I'm highlighting?
Decreases.
Is that growth or decay?
Growth or decay? Decay.
It's decay. Very good. Okay. So you have to look for those keywords when you're doing a problem like this. You have to know which one refers to growth and which one refers to decay. And sometimes it's obvious. Like sometimes you literally see the word and you can make that justification for it. Okay, so we're going to look at this next one together again. This is more of like reading comprehension than math, but these are math questions on the SAT.
Okay.
All right. So could you read this one out loud for us, please? And then I'll read it.
According to a NASA study of satellite data, the mass of an Antarctic ice sheet increased by 1.12 billion tons of ice each year from 1992 to 2001. For these years, which of the following types of functions best models the mass in tons of the Antarctic ice sheet?
Okay,
As
very good.
function time in years.
Very good. Okay, so I'm going to read it out loud. I'm going to highlight some keywords. According to a NASA study of satellite data, the mass of the Antarctic ice sheet increased, okay, by 112 billion each year.
Uh-huh.
Okay. So when I see the word increase, I know that that's growth.
Okay.
Okay. So when I go down here to the answers, okay, we're looking for two that say growth or increase. So which two answers are growth or increase?
Growth or increase.
Which two answers have the word growth or increase in them?
C and D.
What is this word in D?
Decreasing. It's C and A.
Okay, so we know that it's either A or C because it's increasing. Okay.
Yeah.
Now, is this 112 billion? Is it a percent?
Uh-huh.
That's a question, Sourish. Is it a percent?
Is that a percent? No.
It's a just a number. So
Uh-huh.
whenever it's just a number, that means that it's linear.
Uh-huh. Okay. Yeah.
Just a moment here. It's a little lag here on this. Yeah, so this just tells you that it's a number. It's linear.
All right.
All right. So let's look at let's look at one more of these. All right, here we go. So I want you to read this and see if there's a word in here that tells you whether it's growth or decay, increasing or decreasing. Tell me if there's a word. There's one significant word here.
P.
Nope, P is not a word. Sorry, P is a letter. There's a word.
You mean the population, right?
I'm saying I want you to read this, and there's a word in here that tells you whether this is growth or decay,
Okay. A
increasing or
biology class at Central High School predicted that a local population of animals will double in size every 12 years. The population at the beginning of 2014 was estimated to be 50 animals. If P represents the population n years after 2014, then which of the following equations represents the class's model of the population over time?
Okay, now I'm going to read it. A biology class at Central High School predicted that a local population of animals will double in size every 12 years. The population at the beginning of 2014 was estimated to be 50 animals. If P represents the population N after years after 2014, then which of the following equation represents the class's model of the population over time? Which word did I emphasize when I spoke this? Did you hear me emphasizing?
Yeah,
What does this word mean?
double.
Yeah, what does
Or
it
it's
mean?
going to be increasing.
It's
Like,
increasing. Very good. Or it's growing, right?
yeah.
Okay, very good. Now, how much are they starting with? What's the initial amount that they're starting with? That's a question for you, Sourish. How much are they starting with?
They're starting first of all, they're starting with 50 animals.
That's right. That's exactly the right number here. Okay. Very good. Okay. Yeah, I know this is not easy for you because you're used to just having to um, do some calculations, but it's always good if you can interpret what's going on. Okay, let's look at one more. I think we've got time for one more, at least. Snip this. Okay, so new question here. All right, so it says the half-life of the radioactive isotope iodine-131 is approximately 8 days, which means that at the end of each 8-day time interval, only half of the mass of the isotope that was present at the beginning of the time interval remains. Which of the following best describes how the amount of iodine-131 changes over time? So is this a growth or decay? Growth or decay, Sourish?
Growth.
Or you can
DK.
think of it as, is they're increasing or decreasing? Okay, now I agree with what you just said. Which word or words tells you that it's decay or decreasing? Is there any words in here that tell you that it's increasing or decreasing?
It's decreasing.
I know, but which words tell you that? Which, because I don't know if you're just guessing or if
It's
there's
only half of the mass. I believe it's half.
exactly half life, half of the mass. Perfect. Perfect. Okay. Well done. All right. I think that will do it for us for tonight here. Let me stop the recording.